Nomenclature of alkanes. Hydrocarbons can be classified into two, aliphatic and aromatic, also known as arene. Aliphatic can be classified into four, alkanes, cycloalkanes, alkenes, and alkynes. For alkanes and cycloalkanes, only single bond or sigma bond involved in the bonding of the compound, while for alkane, the bond is between carbon-carbon double bond, and for alkynes, the bond involved is carbon-carbon triple bond. Compound type and general formula for a cyclic alkane is CnH2n plus 2. The number of n must equal to 1 or greater than 1. This is the general formula for a cyclic alkene. A cyclic alkene means the alkene which has no cyclic ring. For cycloalkane, the general formula is CnH2n. N must be equal to 3 or greater than 3. Alkene general formula is the same as general formula of cycloalkane. For cycloalkene, the general formula is CnH2n minus 2, and it has the same general formula with alkyne, carbon-carbon triple bond. Saturated versus unsaturated hydrocarbon. Saturated hydrocarbon contains only single bonds between carbon and hydrogen atoms. It is named saturated because it has the maximum number of bonded hydrogen atoms. Unsaturated hydrocarbon contains one or more double bonds or triple bond. For example, for alkane contains single bond only, so alkane is a type of saturated hydrocarbon. This is a cyclic alkane, this is cyclic alkane or cycloalkane. And this one, unsaturated hydrocarbon, contains one or more double bonds or triple bonds, for example, alkene and alkyne. Or aromatic ring as well, because aromatic ring has carbon-carbon double bond. Alkanes, aliphatic and saturated hydrocarbons have only sigma bonds and no functional groups. The categories can be a cyclic alkane, general formula CnH2n plus 2 where n is equal to 1 or greater than 1. Cycloalkane, the general formula CnH2n where n is equal to or greater than 3. So these are the example of a cyclic alkane. Ethane and propane contain sigma bonds only. For cycloalkane, the carbon-carbon bond is bonded to form a ring, so that is cyclo. The examples of cycloalkanes is cyclopentane and cyclohexane. IUPAC system of nomenclature. IUPAC means International Union of Pure and Applied Chemistry. The name of the alkane when the number of carbon atom of the alkane compound is 1, the name of the alkane is methane. Carbon atom 2, ethane, carbon atom 3, propane, carbon atom 4, butane, carbon atom 5, pentane, and so on until carbon atom number 100. You have to memorize the number of carbon atom, at least 10 carbon atom from methane to decane. So if you realize the name ending in A and E means this is the group alkane, homologous series alkane. So this is how you name the alkane using IUPAC name. prefix at the front, you start with the prefix at the front, and then parent in the middle, suffix at the end of the name. Prefix shows where all the substituents, parent, how many carbon, suffix, what family. Now we are discussing about alkane, so the family suffix is A and E, ane. Carbon substituents are branches bonded to a long carbon chain. Our long carbon chain is the parent. Substituent formed by removing one hydrogen from an alkane. So if the parent name is methane, because it has one carbon, the name is methane. And if one carbon becomes the branch or the substituent, you remove the A and E at the back and you replace with YL. If it is the branch, remove A and E, replace with YL, showing that is the branch or the substituent. So if it is methane, means one carbon atom becomes a branch, you call it as methyl. If two carbon atoms becomes a branch, the name is ethyl. And then if you have 3 carbon becomes a branch, propyl, 4 carbon butyl, 5 carbon pentyl. So these are the names of the alkyl group or the branch. For example, here let's start with the parent name. Find the longest carbon chain. The parent name is propane. Prop. The parent name prop. Ane is an alkane, the suffix ane, alkane. And then the substituent is the branch. So it has one branch here, one carbon atom as a branch, and the carbon atom position is at carbon number 2. The parent is carbon number 2. So the prefix is 2-methyl, means this 1-methyl, one carbon branch is at carbon number 2. So 2-methyl propane. Steps in naming alkane. The first step is find the longest carbon chain. That longest carbon chain will be the parent chain. Step 2, number the parent carbon chain. After you found the longest carbon chain, you have to put number for each carbon on the parent chain. And then step 3, identify and number the substituent. The final step is write the name as a single word. There is no space in naming. Make sure it is a single word. Step 1, find the longest carbon chain. So if you count the carbon, 1, 2, 3, 4, 5, 6 carbon in total. 1, 2, 3, 4, 5, 6, 7. So here 7 carbon in total. This is the longest carbon chain, not the total 6. It doesn't matter whether it is a straight carbon chain or bent. So this is the parent, 7 carbon, so parent name is heptane. The substituent is methyl. Here 1 carbon substituent, methyl. So 2 carbon substituent, this is ethyl. So the correct parent name is heptane. So circle this longest carbon chain. So this is heptane. This is the parent name. And then if there are 2 chains of equal length, if the straight line and the bend has 2 equal carbon, both have equal number of carbon, pick the chain with more substituent. For example, here you have 1, 2, 3, 4, 5, 6 carbon in total, the longest 6 carbon, and 1, 2, 3, 4, 5, 6. When you bend, the longest carbon chain is also 6 carbon. But we have to pick the chain with more substituent. If you choose this is the longest carbon chain, you will have two substituents here, one methyl, one ethyl. If you choose hexane band as the parent carbon, as the parent chain, longest carbon chain, it has one substituent only. How to count the number of substituent? Count the number of bond of the branch attached to the parent. This is one bond attached to the parent, second bond attached to the parent. For this one, only one branch bond attached to the longest carbon chain. So here, only one substituent. This structure has two substituents. So this is the correct longest carbon chain. Step number 2, number the parent carbon. After you choose the longest carbon chain, you have to number that parent carbon chain by giving the first substituent the lower number. Now our longest carbon chain is 1, 2, 3, 4, 5, 6. 6 carbon in total. This is the parent hexane, 6 carbon in total. But then you have to number the 6 carbon. You have to put the number from the right. Because when you put number 1 from the right, the number 2, the first substituent will have the number 2. This substituent will attach at carbon number 2. If you give the number of carbon from the left, start numbering from the left, 1, 2, 3, 4, 5, the substituent will be attached to carbon number 5. Wrong. We have to make sure the substituent attached to the lower number of parent. If the first substituent is the same distance from both ends, number the chain to give the second substituent lower number. For example, here, you start counting from the left, 1, 2. So carbon number 2, substituent at carbon number 2. And then if you start numbering this carbon as carbon number 1, this substituent will get attached to carbon number 2 as well. So the first substituent, same distance from both ends. If you put the number from the left, number 1, or number 1 from the right, both substituent will get number 2. Same distance from both ends. So we have to number the chain to give the second substituent the lower number. Okay, so this is our substituent, first substituent. If we count from the left, this is our first substituent. If we count from the right, this is the first substituent. So let's look at the second substituent. Our second substituent, if we start counting from the right, the first substituent, number 2. The second and third substituent, number 4. 1, 2, 3, 4. Second and third substituent, number 4. If we start counting from the left, the first and second substituent, number 2, and then the third substituent, number 4. So lower number, you will get substituent number from the left 2 to 4, the number of substituent, from the right 2, 4, 4. So we choose start counting from the left, because if you total these three numbers, you will get lower number. From the right, 2, 4, 4. If you total these numbers, you will get bigger number. So we choose a substituent that has lower number. So you have to start counting the parent or numbering the parent from the left, not from the right. Step number 3, identify and number the substituent. Based on the parent number, if the location of two different substituents are same from both ends of the main chain or the parent chain, assign the lower number alphabetically to the first substituent. For example, here we have 6 carbon chain. The longest carbon chain is 6, so the name of the parent is hexane. Start counting from the right, because the name of the substituent we have to follow alphabetically. If you start counting from the right, 3. If you start counting from the left, 1, 2, 3 as well. So 2 different substituent, same from both ends. Both will get number 3. So we have to choose whether we have to start numbering the carbon number 1 from left or from the right. So we choose based on the alphabetical order of the name of the branch or substituent. So this carbon branch, total carbon is 2 carbon. Here 1 carbon. When alkyl group, 2 carbons in total, the name is ethyl. This one, 1 carbon, the name is methyl. So give the lower number according to alphabetically order. E first and then M. Ethyl and then methyl. So that's why we have to give the number of the carbon number 1 from the right. Step number 4. Write the name as a single word, means no spacing. You have to separate the number from letter by hyphen, so this is hyphen or dash, and then separate numbers with numbers by comma. If number and number, separate by comma. If number and letter, separate by hyphen or dash. For example, here hexane parent name and then methyl branch at carbon number 2. So number and letter separate using hyphen. Letter and letter, no spacing at all. Make sure there is no spacing in naming. If 2 or more different substituents are present, write them in alphabetical order. So here, start counting from the left because the substituent will get number 2. And then here, number 2, methyl at number 2, and then ethyl at number 3. So we have substituent 2 ethyl, 3 methyl. Parent name hexane. Longest chain 6 carbons in total. So parent name hexane with 2 substituent 2 ethyl and 3 methyl. And then we have to write the name according to alphabetical order. E first and then M. So the name of this compound is 2 ethyl 3 methyl hexane. Here, number and letter hyphen, letter number hyphen, number letter hyphen. Here, letter letter, no space at all. And remember, number and number, comma. When 2 or more substituents are identical, these 2 substituents are different, 1 ethyl, 1 methyl. If 2 or more substituents are identical, indicate this using prefixes di, tri, tetra, penta, hexa. Di means 2, tri means 3, tetra means 4, penta means 5, and hexa means 6. In deciding on alphabetical order, ignore di, tri, tetra, penta. So don't consider this D in arranging the alphabetical order. Just ignore D, T, here T, ignore that one. Take the alphabet, the first letter of the substituent, not how many substituent. Make sure each substituent has a number. Here, longest carbon chain, 9 carbon in total, no name. And start counting from the right because the first substituent has lower number, number 3. If you start counting from the left, this substituent will get number 3 as well. And then the second substituent, if you start counting from the right, second substituent will get number 4. If you start counting from the left, the second substituent will get number 6. So we want the lower number. We prefer 3, 4, 7 instead of 3, 6, 7. So we prefer the lower number. the substituent 3-ethyl at carbon number 3, ethyl substituent at carbon number 4, and carbon number 7, both methyl. So we write as 4, 7 number, comma 4, 7 hyphen number with letter hyphen dimethyl. Dimethyl means 2-methyl. Di means 2. The parent is no name, longest carbon. So the full name is, we look at E here, alphabet E. In deciding alphabetical order, ignore prefixes. So we ignore di, we look at M, methyl. So E first and then M. So the name is 3-ethyl 4,7-dimethyl, no name. Branch alkyl groups. Carbon branch must be numbered as well. Numbering always begins at the point where the group is attached to the parent chain. So here, if we look at this structure, this blue bond here is the bond of the branch with the parent. So there's no parent here. This structure only shows the branch. So this is the bond to the parents. Let's say you have parent longest carbon here, and these 4 total carbons are the branch. If you look at properly, it looks like there is a branch on a branch. Okay, the methyl on the branch, because this carbon attached to parent here, parent, and then you call this as a branch, this carbon or this carbon as a branch carbon. And then if you look at this carbon branch is on the branch. So that is branch alkyl group. The alkyl group has branch in the branch. And then here you start counting the carbon branch. Carbon number 1 must be the carbon that is attached to the parent. So if this is carbon number 1, this is carbon number 2, carbon number 3, not 1, 2. You select the longest carbon as well. Okay, this is carbon 1, the carbon that is attached to the parent, that is carbon number 1. For this one, this is the bond attached with the parent, carbon number 1, 2, 3, or 1, 2, 3, same. And then this carbon attached to the parent, this carbon has to be carbon number 1, not this carbon, not this carbon. We select the carbon that is attached to the parent as carbon number 1. So this is numbering the carbon on the branch. Let's see the alkyl branch propyl. So propyl, this is the bond with the parent, and then the branch, the total number of carbon of the branch are 3. So the 3 carbon straight chain, you call it propyl. This 3 propyl. And this one, this is the bond with the parent, and the carbon number 1 is the carbon that is attached with the parent. And you look at the total number of carbon of the branch. The total number of carbon of the branch are 3 carbons. And you have to number the carbon number 1 that is attached to parent, and then this is carbon number 2. Okay, so the branch on the branch is at carbon number 1. So you have 1 methyl at carbon number 1. If a methyl is attached to the second last carbon branch, because this total number of carbon only 2, means this is the last carbon. If you have until 5, the second last is carbon number 4. Here only 2 carbons in total. Here only 2 carbon, carbon 1, carbon 2. So the second last carbon is carbon 1. If a methyl is attached to the second last carbon that is attached to the parent, the name is iso. Iso means a methyl attached to the second last carbon branch. That is what iso means. Propyl, total number of carbon in the branch. So this is the isopropyl. Next, straight carbon chain branch, butyl, total 4 carbon, butyl. And then here, this is the bond with the parent, and this is the branch. So the total number of carbon in the branch are 4 carbons. This must be carbon number 1 because this carbon attached to the parent. So this is carbon number 1, carbon number 2, carbon number 3. So if you look at a methyl is attached to the second last carbon, because our last carbon is carbon 3. The second last carbon is carbon number 2. If a methyl is attached to the second last carbon, this is iso shape. So the name of this alkyl branch is isobutyl. Next, total number of carbon branch 4. So butyl, this is carbon number 1 because this carbon attached to the parent. Carbon 2, carbon 3. If a methyl is attached to the first carbon of the branch, the name is sec. Here, iso, methyl attached to the second last carbon. You name it as iso. If the methyl attached to the first carbon of the branch, the name is sec. Butyl, total number of carbon branch. So sec butyl. Sec means the position of a methyl group at carbon number 1. Next, third butyl. Butyl, total number of carbon in the branch. Third means there are 2 methyl groups attached to the first carbon of the branch. This is the first carbon of the branch because this carbon attached to the parent chain. Carbon 1, carbon 2. And then, if there are 2 methyl groups attached to carbon number 1, the name is third butyl because total number of carbon are 4 carbons in total. Next, total number of carbon branch 5 carbon, so pentyl. This bond attached to the parent chain. And then, if that compound has 2 methyl groups attached to the second last carbon branch. This is the first carbon because it is attached to the parent, first, second, and third. The last carbon is the third carbon, means the second last carbon is the second carbon. If there are 2 methyl groups attached to the second last carbon, the name is neo. If 2 methyl groups attached to the first carbon, the name is third. 2 methyls attached to second last, neo. Neopentyl because total number of carbon in the branch are 5 carbons in total. Prefix iso is considered part of alkyl group name for alphabetizing purpose, but sec and third are not considered. So if iso, if you have to arrange in alphabetical order, so we take account the I. And then if sec or third, we ignore the S, ignore the T. We take the number or the name of the branch. We take the name of the branch. Butyl B, listed under B. Okay, so here we have to put according to the alphabetical order, put the order of the name of the substituent order according to the alphabetical order. So the parent name at the back, substituent at the front. So you have to decide which substituent that you have to write first according to the alphabetical order. So you have to write 4-iso, I first, and then M. So that's why 4-isopropyl 2-methyl, not 2-methyl 4-isopropyl. Iso first because I first and then M, according to alphabetical order. Here, 4-butyl 2-methyl, we put 4-butyl first because it is B. We ignore T. Sec and third are not considered. So 4-third butyl. So B first and then M. So the name is 4-third butyl 2-methyl, not 2-methyl 4-third butyl. Okay, according to the alphabetical order, B first and then M.